All right, so today we are going to talk about solid geometry, and it's a lot of vocabulary and just being able to identify their different pieces. So, three-dimensional figures or solids can be made up of flat or curved surfaces. Each flat surface is called a face. An edge is the segment that is the intersection of two faces, and a vertex is the point that is the intersection of three or more faces. So if you're looking at this, because a face is a flat surface, that would be this top box. And then an edge would be this line over here because we have this back side and this side of this rectangular prism touching it. And then the red dot would be a vertex. And a lot of you probably already know these terms, and that's totally fine. So some of our three-dimensional figures, a prism is formed by two parallel congruent polygonal faces called bases. And so if you notice, in this picture, we have these two triangles that are congruent, so those are our bases. Now, the next one is a cylinder, and it is formed by two parallel congruent circular bases. So it's really close to just a regular prism, except when the bases are circular, it is a cylinder. The next one, a pyramid, is formed by a polygonal base and a triangular faces meeting at a common vertex. So you notice our base, in this case, is a triangle, so this would be a triangular, and then it's a pyramid because they all come to the one point instead of having another triangle at the top, kind of like with the prisms. So then last but not least, we have a cone is formed by a circular base and a curved surface that connects the base to a vertex. So it's kind of like a circular pyramid, but obviously we call it a cone instead. So this is just another special one. A blank is a prism with 6 square faces. Well, if you think about it, if all of the faces are squares, then that would be like a cube. So this is a cube. Oops, can't write today. And other prisms and pyramids are also named by the shape of their bases. So that's something that is important to understand, because when we talk about prisms, if you have to name them, you have to be able to say, well, it's a rectangular prism or a triangular prism or whatever it may be. So we're just going to sketch these real quick. If you're not an artist, it's not the end of the world. So because this is a triangular prism, triangular tells me that my base is a triangle. So I'm going to go ahead and just draw a triangle. And actually, I'm going to draw it just sideways so I can actually... So then, because it's a prism, that means I need that triangle again because the bases have to be congruent. So I just draw it floating above where it was, and then I connect my lines. And if it bugs you that that back line can be seen even though it's not actually seen, you can just make it a dotted line like that. For a rectangular prism, we are going to have a rectangle. But then, because it's a prism, we have 2 of them. And again, they should be congruent. And for the sake of not having to erase lines, I'm going to just go ahead and draw it. If you are not an artist, though, again, just draw 2 rectangles that look the same. And then connect your points. Which mine is not perfectly drawn. But you can see my rectangles and my bases. So a pentagonal prism. Pentagonal means that there's 5 sides. So we draw a pentagon, and the easiest way is to just kind of draw like a little house. So do, like that. And then because it's another prism, that means I need to have 2 of these bases. So I'm just going to draw this one slightly offset from the other one. It's not quite the same shape. Crap. Let's try that again. So then... you're just connecting your sides to the sides they correspond to, and this is not a good one. So I'm just going to restart. If you're ever drawing and you just think it looks terrible, feel free to restart. We are all human. It happens. So then this would come down like that. This would come back. And again, your pictures do not have to be perfect. If you feel like you draw it and it does not look like it should, just draw a little arrow to your base or something. Tell me it's a pentagon. I mean, use your best judgment, but if you think I can't tell what it is, tell me what your base is. Tell me there's two bases. You know, use words to describe it if you have to. For a hexagonal prism, your base is going to have 6 sides. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So then when I connect these, you're connecting your corresponding points to each other. And it gets kind of messy with these when you get to the ones that aren't actually, aren't truly visible, because when you get those dotted lines thrown in there, it can get kind of confusing. But just, again, do your best, okay? So then a triangular pyramid, because it's a pyramid, I know it meets at the top, and because it's triangular, I know my base is a triangle, so I draw a triangle, and the easiest way to draw a pyramid is to just draw a point and then connect everything to that point. And actually, this one's probably not going to look very good because I didn't offset it. So we go boop, 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 just like that. And again, if that back line is messing with you, make it a dotted, like that. For a rectangular pyramid, change the color. Wait, I did that one. For a rectangular pyramid, we know it meets at one point because it's a pyramid, and we have a rectangle at the bottom. So we draw a rectangle, we pick a point, and we just connect everything to that point. And I knew that was going to happen. Try again. Little did you know you're taking an art class today. And that one technically is dotted. And so are these two. So sometimes I know for me, I like to keep the solid lines there for a minute just so I actually can still see it. And then I'll go back and change it to dotted, even though it's kind of a pain. With a pentagonal pyramid, you're going to do the exact same thing, but, come on, pick the color. Let's draw. Okay, so we're going to have a pentagon. So again, draw a pentagon. Okay, and then this pentagon has to meet at one point because it's a pyramid. So then I'm going to connect. I know I can see that side. I know I can see that side, which that's kind of curvy. So let me try and fix that. Boop. I know I can see this one, and I know I can see this one. And just by doing that, I can tell, didn't want that one to go away, that this is going to be dotted, and this one over here is also going to be dotted. And then you'll have a little bit dotted there. For a hexagonal pyramid, we are going to have a hexagon, and we're going to have a pyramid, so it meets at a point. So we have our hexagon, 1, 2, 3, 4, 5, 6. And meeting at a point, we're just going to draw it up there. And again, for me, it's really confusing to have all those lines, and I have a bad habit of drawing these so that I can't actually see what I'm doing anymore. Boop, 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 boop. But you notice, again, if you don't think I can see what it is, that's a hexagon. So you just label hexagon, and I'll be able to tell you're trying to make a pyramid. So in order to classify figures, you have to be able to name vertices, edges, and bases. So if we look at this shape right here, this is a triangular prism. And the reason why is because the base is a triangle, and there's 2 of them, even though we can't see that second one because it's hidden. So in order to name vertices, we'll start with the gold. Vertices, remember, is where 3 or more faces come together. So if you look at this, the vertices would be like here, here, here. And notice we only have 1 letter at each of those. So that would be B, A, F. And by the way, this is supposed to be a B. It got cut off in the notes for some reason. So we have B, A, F, and then down here we also have D, C, and E. D, C, E. Now, for the edges, remember the edges are where two or more faces come together. So I'm going to erase these. So with these edges, you have to be really careful because it's really easy to forget them. If it is easier for you, you can draw yourself a little line in the back so that you can see it a little bit easier where that other side is. But looking at these edges, is just start at the top. If I start this B, I have BA, BF, and BD. So BA, BF, and BD. Okay, so then I'm going to change my highlighter color to make it a little bit easier. If I am at A, I would have AB, which I already have, so I don't need to worry about, AE, and AF. So the only ones I need to add are AE and AF. And that takes care of all of my edges for B and A. And for F, almost, because if you notice with F, we have that one and that one. But F also has this one on the front, that FC. So we're just going to add it in there. And then we're left with just the three sides at the bottom. So that would be DE, EC. Ooh, that DE looks terrible. DE, EC, and CD. And so then a really easy way to check yourself is just count your sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got them all. Yay, us. So then to classify your base, it's pretty straightforward. All you have to do is tell me the triangles. So our bases are triangle BAF, because that's the top, and triangle DCE. So you're just giving me the shape and then the letters that represent that shape. All right, so the next thing is called a net. And a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. To identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. Sorry, I'm coughing. Okay, so looking at this shape, we have 6 faces, 1, 2, 3, 4, 5, 6, and all of them are squares. So because I have 6 faces and all of them are squares, I know it has to be something with a square. But then, remember, we have prisms and pyramids pretty much. And with a pyramid, it meets at one point, so I know this is a prism. And then since all of these are squares, a prism that has squares for its sides is called a cube. Okay, and if you think about it, this side over here would fold up, as with this side and this side. So that would kind of make like an open box, and then this little piece at the end would be like the top of the box, and it would just all fold over. And you can use your brain a little bit to help you picture it, but really it's just up to what makes sense to you. So then for this one, we notice that we have a circle, and then we have this weird like half circle thing. So then if you think about the shapes that we know about that have circles, we either have a cylinder, or remember a cylinder has 2 of those bases, or a cone. Well, we don't have 2 circles to pick from, so we know it's not cylinder, so then we are left with a cone. And what happens is this little side on this half circle just wraps around this circle, and then this line on this side just makes a point. And you can see that if you just roll a piece of paper like around a curve, it's going to make a point like a cone. So then our next piece is cross sections. And a cross section is the intersection of a three-dimensional figure and a plane. So whenever we do cross sections, you're going to have to be able to just identify what shape is made. So why is this not working? Come on. It's just being special today. So if you notice, this is a pentagonal pyramid, right? Because the base is a pentagon and this comes to a point, so it's a pyramid. And if I take this plane, which is this green little thing, it's almost like I'm just slicing the top part of that pyramid off. And if I do that, you notice that the shape in the middle is another pentagon. So your cross section is a pentagon. I'm just going to say cross section pentagon. Okay. For this next one, this has 1, 2, 3, 4, 5, 6 sides. So I know that the shape is a hexagonal. And thinking of if it's a pyramid or a prism, remember it has 2 of these bases. So this is going to be a prism. So then if I were to take this prism and cut it in half with this little gold piece, okay, it's like a magician almost. Notice on the inside we have another hexagon. Yay! So then cross section is a hexagon. And by the way, whenever we ask you to describe the cross section, the only thing we are really looking for is this part right here. I'm just going over the shapes too, just to make sure you're understanding all that. So last but not least, we have a cone because it has 1 point and a circular base. So then if you take this cone and you cut it in half, you're slicing that cone in half. And if you did that, you can see on the inside, it makes a little triangle. Now, for some of you, it may be hard to see some of these because, like in this case, it's kind of cockeyed. But just remember, if you were to cut it looking straight at it, what would it look like? And again, you're probably just going to have to use your imagination a little bit for this. But just make sure that you are able to identify what happens when it is cut. And that is actually the end of it. Yay! So if you don't have the 11.1 homework sheet, make sure you come and get it from me. Otherwise, hopefully everything makes sense.